Installing a wireless network in an enterprise environment, we probably need more than just one access point. And there are two basic schools of thought when it comes to managing multiple access points. One is to use autonomous access points. With autonomous APs, we manage each access point individually. They each have their own unique IP address. We go to each one and maybe configure them with identical wireless network names or identical SSIDs, and that allows our clients to roam from one access point to the other. However, it's just not scalable to manage individual access points if we have hundreds or even thousands of access points. So typically in an enterprise environment, we're going to use lightweight access points. With lightweight access points, we're going to be able to configure and control multiple access points from a single wireless LAN controller. And the traffic typically goes from one access point through the wireless LAN controller and then out to the egress access point. And the protocol that we used to use between a wireless LAN controller and an access point was called LWAPP, the Lightweight Access Point Protocol. But in today's networks, you're much more likely to find CAPWAP. That stands for Control and Provisioning of Wireless Access Points. And since we're talking about enterprise networks in our discussion, our focus is going to be on lightweight access points. And in this video, we're going to consider a few different deployment options for lightweight access points. One is to have a distributed wireless LAN controller deployment. That's where we might have access points in our different buildings on campus, and the wireless LAN controller or controllers controlling those access points would be local to those access points, maybe in the same building. That's an example of a distributed wireless LAN controller deployment. However, we might have an enterprise and it has lots of buildings, and one of those buildings is designated as a data center. Well, perhaps we put our wireless LAN controllers in that data center and allow the access points from around the enterprise to communicate with that centralized repository of wireless LAN controllers. And those controllers could be physical devices that are rack mounted, or Cisco allows us to virtualize our wireless LAN controllers and run them as a VM, a virtual machine. And we can do that in our data center, or since they can be virtualized, we might connect out to a cloud provider, perhaps through the internet, and we could install as virtual machines in that cloud provider our wireless LAN controllers. And that would allow us to have a cloud WLC deployment where our access points within our enterprise were being configured and controlled by one or more wireless LAN controllers that lived in the cloud. And one final option I'd like you to consider is a branch office. Let's say that we've got this remote branch office and perhaps it only has a couple of access points. And we might conclude that it's not worth putting wireless LAN controllers in that branch office. What we could do instead is just leave the wireless LAN controllers back at the campus data center and have those access points be controlled by that campus data center collection of WLCs. However, as we look at traffic patterns, it doesn't seem terribly efficient if I'm going from one VLAN in the branch office to another VLAN in the branch office for that traffic to traverse the WAN and then come all the way back to the branch office. Well, we don't have to do that because Cisco gives us the option to use the Cisco Flex Connect feature. This is going to allow us to configure and control a remote wireless network. And there are a couple of ways that we could do this. One, which is probably not recommended in this instance, is central switched. This is going to operate as we would traditionally operate in an enterprise environment, where all of our wireless traffic goes back to the wireless LAN controller, but that's going to require that we span the WAN and take up WAN bandwidth when really the traffic needs to stay local to the branch office. And as a result, this is typically not the recommended mode of operation for a situation like this. Instead, we can use local switched. With local switched, that end user traffic can stay local to the branch office, and the access points will be intelligent enough to properly forward that end user traffic. And I emphasize that this is end user traffic that's staying local because we're still going to be using CAPWAP to communicate with that centralized repository of wireless LAN controllers back at the data center. So we are going to be going over the WAN, but just for control and management traffic. And that's a look at a few deployment options for wireless LAN controllers in an enterprise network.